So all of these functions in this file are cluttering the file up a little bit. It's not that big a file. I could keep on adding to it and be fine, but there's a lot of stuff going on in here, and I really want to be able to move some of these things into other files so that I can keep main.cpp focused on one or two things. I'd like to have a file that just takes care of this function and any functions that are related to getting input in a safe way, and then I could have another file that has maybe these two functions, which the file just is full of functions that are related to validating input and making sure that input is good. And I could run some code and main in here. But anyway, let me show you how to do that. Before I do that, I need to show you that you can move a function around inside of a file. So I can take get number and I can move it to someplace else in the file, like I can put it here in main, just above main, and if I run it, oh, now it gives me errors because run some code needs get number. Get number is declared down here and defined down here, and that's two separate things, declaration and definition. But here, run some code is expecting to use it, and it's giving me an error because it was expecting to have it by now, or at least to know what it is. And it doesn't know what it is. So this right here is a function definition, but I can go up here and do what we call a function prototype, which is a declaration. And this isn't really a function, this is a promise to the compiler that there will be a getNumber function sometime in the future. So when I compile this, the program's fine. It's able to compile because when run some code, which I'm not even calling anywhere. Am I calling it? I don't think so. No, I'm not even calling it, but when run some code is trying to compile, it recognizes, hey, I need a function called getNumber because I need to pass this argument to it. What's going on, compiler? Where am I going to find this function? Meanwhile, the compiler was told, don't worry, if you see this getNumber thing being referenced somewhere, don't worry about it. I promise by the time the program executes, everything will be in order. Everything will be there. So that allows everything to work if you have these function prototypes. And if you have those prototypes, you can actually put this function anywhere, including a separate file. So I'm going to do that. I'm going to make, oh, don't need all this stuff. I'm going to make a new source file, new item. I'll call it input, safe input, add. And then I'll grab get number, I'll take this whole thing and put it here. Now, inside of safeinput.cpp, this CPP file is going to be compiled separately from main.cpp, which means that this CPP file needs to have all of this information that is required to make these functions work. Safe input needs to know what cin is, which is why I need to pound include iostream using namespace std. And now this will work just fine. I can compile this, and everything works. I'm going to make a new file, add new item, called validate. And inside of validate, I'm going to put the validation functions I have, which is the isWithinRange and the isValidInput. I'm just going to cut those out and put them in here. And these don't even need any special libraries. They're pretty self-contained. So now, I don't even have to run this code. I know that it's not going to compile. isWithinRange, it doesn't know what isWithinRange is. It's because, I'll just show you running it, it'll give me the same error. It's because it was never told that there's going to be a function called isWithinRange anywhere. I need to prototype this function as well. Now there are a couple ways I can do that. I can take the is within range signature, that's another term for this right here, and paste it here so I can make a function prototype just like I did for getNumber. And if I try to compile this, it'll actually give me another error because now it doesn't know where isValidInput is. Let me just do that as well. IsValidInput's signature, put that here, semicolon. The prototypes end with a semicolon. So that's how you know that they're prototypes, whereas the definitions have the curly brackets afterwards. And now the program should compile. There we go. So you can make functions in different files, and you can make libraries this way, but it would be kind of a hassle if for every single function you needed to prototype it like this. So what programmers did is they created header files that will include all of these prototypes for you. For example, I'm going to add a new item, a header file, not a .cpp. Make sure that you know the difference between a .cpp and a .h. And I'm going to call this one validate. And I'll put the prototypes for is within range and is valid input in here. Then in main.cpp, instead of having those there, I can do this, pound include double quotes validate.h. The double quotes mean look in this directory before you look in the libraries for Visual Studio. And when I run this code, even though I don't have the prototypes in main.cpp, I have them in validate.h, and validate.h is included in this file. Pound include, what it really actually does is cut and paste everything in this file and put it in here. When we pound include conio.h, what we're doing is we're including a whole bunch of prototypes for all of the functions that conio.cpp someplace has defined for us. It's a little bit different than that. The conio functions are already compiled into libraries, but they can still be referenced using the header file. And again, all the header file has is just prototypes like this that explain how to use the functions that are made available to us by these libraries. I want to show you a little bit more detail about function arguments, because these are pretty important. Here in drawLetter, we have two arguments that are passed. This first one is a character, the second one is an integer, and both of these are passed by value, which means that when drawLine is called, the pound sign is put into this variable here, charLetter, and letter is a brand new variable that has been given a copy of this data right here. If I made a char letter equals question mark and I did letter, then when drawAlign is called, a new variable is made on the stack and it's given a copy of the value that was passed in as an argument. So if I did something at the end like letter equals period, I'll go ahead and print out letter here and run it. Whoa, char letter redefinition. Oh, right. Don't need that one there now. So let me run that. So it printed 10 question marks, but why did it not print a... Oh, it actually printed 11 question marks, didn't it? Let me just double check that. I'm going to make this a 3 so we can tell the difference more easily. Yeah, it printed 4 question marks. It printed the 3 from here and then another one here for letter. Even though letter was changed to a dot, it wasn't changing this letter, it was changing this letter. And this letter right here is a brand new variable. However, if I do this, ampersand, now this is what we call passing by reference. And whatever happens to letter inside of this function is going to modify the letter out here. So if I run this, now it'll print out a dot. Because when the function calls, it'll print 3 question marks. And before this function is finished, it will set letter to period. Then when I try to print letter after running this function, it'll print out a period because it's been passed by reference and modified inside of the function. The function variable is a different variable typically. If you don't have this ampersand here, this variable is a different variable than this one. In fact, because it's different, programmers often name it something that very explicitly defines it as existing only within the scope of this function. So this right here means argument. It means that this letter, this variable, is going to disappear and won't affect anything else at the end of this function. Unless, again, we do this ampersand thing, now whatever changes we make to a letter will happen outside. Without the ampersand, it's whatever happens in draw a line stays in draw a line, and with it, what happens in draw a line will change the outside. So I put the ampersand in there, which means, again, the letter should be a dot. There we go. You can make as many arguments pass by reference as you want, just like you can make as many arguments pass by value. Another way to do this same thing is with a pointer, and that would look like this: address of letter. And I'll show you guys pointer in another lecture. But as a preview, all this is doing is passing a reference to a letter, and this right here is saying grab the thing at the end of that reference, and that's what we're going to print out. This is saying grab the thing at the end of the reference and set it to be a period. I'll show you that in another YouTube video. Some of you may have noticed that I'm not using any global variables in any of the YouTube videos that I'm showing you. And that's because I've made a habit of not using any global variables. There are situations where I have to use them, but those are very specific situations when I'm dealing with a complicated API forcing people to make global variables. But that's another issue. If you want to write good, clean code, you do not want to use global variables. Let me show you what a global variable is and how it's useful, and then I'm going to explain why it's bad. I'll make a variable here called int letter. Get rid of this and get rid of this. And when I run this, this will run basically the same way. Whoa. Oh, because it's an integer. Silly me. Char. Let's try that again. So there, it runs the same way because letter is the same letter being used everywhere. This makes it so I don't need to pass it in as an argument here, but it also means that the only place that I can ever use this function is in an environment that has access to a global variable called letter. And that's kind of bad. One of the best things about functions is that they make modules of code that you can give to other people or put in other programs. This isValid input function might be really useful in a couple different places. And because I've got a .h file and a .cpp file, it'll be really easy for me to use these in another program. But when you start dealing with global variables, now you put constraints on the whole system, and you force the programmer to deal with these extra variables. Also, every single global variable that you have access to, you can access anywhere in your program, which means that you have this extra thing that you have to think about and remember whenever you're doing anything, because changing a value here may have an impact somewhere else in your code because everything is using the same variable. When you use function arguments instead, you very explicitly define where variables are, where they're used, how they're being used, where they're being passed, and you reduce the scope of your complexity. Again, this has to do with that thing I was talking about earlier, how one of the fundamental challenges of computer science is managing complexity. Another thing I want to show you guys that could also get you into trouble is something called recursion. For example, I'm going to make a function thing, and thing will print out stuff, and then it will call thing again. Hopefully, alarm bells are going off in your head for some of you, because thing will call thing, which will call thing, which will call thing, which will call thing, and every single time thing gets called, it will print stuff. I want to see how many times thing gets called, so I'm going to do this. Int a plus 1, stuff a. There we go. So now I'm going to call thing 0. It will start thing. Thing will print out stuff 0, then it'll call thing again with 1. Before that next thing gets finished, it will call with 2, and then it'll call with 3, and then it'll call with 4, and we'll see something very scary happen, which is called a stack overflow. And there we go. That's what I was looking for. Unhandled exception stack overflow. This is a very bad thing. This right here is the call stack, and this tells us where all of our functions are being called from. And we've basically exhausted our stack. We can't call any more functions, which is why the program crashed here. I'm going to stop this, and instead I'm going to put a limiter here. If a is less than 10. Now, even though it's recursive, it's not infinitely recursive. It's still bad, but it's not as bad. It's not quite a loop either. If this were a loop, it would actually be much smaller on the stack. It would be much faster for the computer to execute. If I wanted to do this exact same thing with a loop, I could instead do it smarter like this. For int I a equals 0. Actually, I'll just take that out. Well, a is less than 10 plus a. Boom. And this will also draw a 10 times. Doing it recursively is a terrible idea. As a rule, you want to avoid recursion unless doing it without recursion is way too hard. And that's kind of a cop-out answer. Until you learn about the order of magnitude of operations, the next thing I say isn't going to make any sense, but you should avoid using recursion on any operation that's bigger than O of n, or even approaching O of n. If you're going to use recursion, you want to use it on something smaller than O of n, like O log n. Anyway, recursion. It's bad, you should avoid it, but it can do interesting things for you if you know what you're doing. One thing that could help recursion, if you do decide to do it, is by adding additional return statements to your code. For example, if a is equal to 10, return. Or if a is greater than 50, return. So for example, if I ran this, it'll stop at 10. But if I change the argument here to 11, now it'll never reach 10 and it'll never end here, but it will end here because a will eventually be greater than 50. So there we go. A return statement can be added to a function to end its execution at any time. You can also add a return statement to a function that has a return type. For example, here, there are 2 returns. So it will prematurely return true if it finds that the input letter is in fact inside of the array that was given as an argument as well. I hope this has been educational, and if you have any questions or comments, let me know.